Morning, guys. Today we're going to take a look at page 4 of the Unit 7 Classwork packet. The focus for today is on a prerequisite skill that you guys are going to need for this chapter, and that skill is how to solve proportional equations. What exactly do I mean by proportional equations? Well, if you take a look at example number 11 right here, you notice that on each side of the equation, I've got fractions. And the variable, in this case x, is just part of the fractions. The way that I solve an equation that has proportional aspects to it, or proportional equations, is I use something called cross multiplication. Let me actually show visually what that means. What it means to cross multiply is to simply multiply the diagonals and to set them equal to each other. So for example number 11, that would mean that 4 times 7 equals 2 times x. 4 and 7 were in the same diagonal, and 2 and x were in the same diagonal. So I multiply the diagonals and set them equal to each other. So 28 equals 2x, and in this case, 14 equals x. And we're done. Now, sometimes it may not be quite that easy. For example, take a look at number 13. Number 13 is going to introduce a little bit more difficulty into it because we're going to end up having to use the distributive property. All right. So number 13 says x minus 1 over 6 equals 13 over 19. Okay, so what we do first is the same thing we did before. We're going to use cross multiplication, meaning multiplying the diagonals, in order to be able to solve. So I'm going to have to multiply the 6 by the 13, and I'm going to have to multiply the 19 by the x minus 1. Now, I'm going to show this the long way, just to make sure you all see where the distributive property is going to come in, okay? So I'm going to have 19 parentheses x minus 1 equals 13 times 6. Notice that the 19 is being multiplied by an algebraic expression, and thus we have to use the distributive property in order to multiply the 19 to each part of that algebraic expression, okay? So from here, we would do distribution on the left. So 19x minus 19. Over here, let's see, 10 times 6 is 60, 3 times 6 is 18, so that equals 78. And now we reduce this down to a basic two-step equation, which we can solve by adding 19 to both sides. So 9 plus 8 is 17. All right. And then I would divide both sides through by 19. And in this particular case, I don't know, what would x be? 20 goes in 4 times. So let's actually work this out. 19 times 5 would be 95, right? This goes in 5 times, minus 50, 45, 95. So I did 2 over 19, and I get 2 19ths. So this is kind of weird, right? That it's giving us a weird fractional answer, but we did everything right. And so I get 5 and 2 19ths, right? I remember at this point, I could have theoretically kept going and made it a decimal, but if you want it to be exact, it's probably better to represent it as a mixed number instead. All right? Okay, so with that being said, let's take a look at the hardest this could possibly get, okay? Which is going to be let's take a look at example number 17. All right, example number 17. So example number 17 gives us something like this, right? X minus 20 over 3 equals x minus 11 over 18. Guys, it's the same process, okay? I'm still going to cross multiply just like I did before. The only difference is that with this example, instead of distributing once, I'm actually going to have 2 separate cases of distribution. Let's watch and see how that works, okay? So over here, I'm going to have 3 distributed to the x minus 11, And over here, I'm going to have 18 distributed to the x minus 20. Now, for some of you, you may actually prefer to simplify a little bit at this step. Notice that 3 and 18 have a GCF, so if you wanted to, I could divide both sides by 3 to turn this into a 1 and this into a 6. However, if you don't see how to do that, no worries. Okay, let's just distribute. So I get 3x minus 33 equals 18x minus 360. Where did I get that? 18 times negative 20 is negative 360. Then I'm going to move the x's to the right-hand side using the subtraction property of equality. I'm going to add 360 to both sides over here. For those of you who struggle with your integers, remember negative 33 plus 360 is the same thing as saying 360 minus 33, right? So this is going to be 327 equals 15x, right? So I'm actually going to write this over here to keep everybody from getting confused. 327 equals 15x. And to get rid of a multiplied 15, divide both sides through by 15. Okay? Now over here, this can be converted into a mixed number if you want. So let's actually do that. So 15 goes into 327 twice minus 30, 2, 7. It goes in once minus 15. And what's the remainder? The remainder is 12. So I put the 12 over 15 and get the following. 21 and 12/15. But you guys know that 12 and 15 have a GCF of 3, so I could reduce that fraction down and get 21 and 4/5. Or for those of you who are decimally inclined, you could say 21.8. Okay? Guys, the big thing here can be summed up in 2 words: cross multiply. When you set up a proportional equation, your goal is to multiply the diagonals and set them equal to each other.